Okay, Assalamualaikum and good morning, everyone. Okay, so for today, we will continue our lecture on root locus. So, for today, we will discuss more on the example from slides 4C. Okay, so before that, so your take-home quiz. So for take-home quiz number 1, I extended deadline to next Monday. Okay, so if you think you have done it wrongly, you can still do correction and resubmit for take home quiz number 1. And also please submit take home quiz number 2 on the same day. Okay, so I've posted the link for take home quiz number 2. So for take home quiz number 1, you just resubmit using the Google form that I have given to you last week. Okay, so your project part 3, the due date is week 11. Okay, so now I want to give you part B. So part B will be root locus, but this time I want you to do it manually. So basically part 3, you do the root locus by using MATLAB, and for part B, I want you to try to sketch the root locus manually, and then you can compare with your answer from MATLAB. Okay, so this is part B and part 3. So the due date is the same, week 11. Okay. Okay, so we can start our lecture. Okay, so a little bit of overview about root locus. So root locus, you have 8 rules in order to sketch the root locus. So the first rule is you need to first determine the poles and zeros of the transfer function. So either closed loop transfer function or open loop transfer function, depending on what is the type of feedback. If the feedback is unity feedback, then you can straight away obtain the poles and zeros from the transfer function of the forward transfer function. If the feedback is not unity, then you need to find closed loop poles, closed loop transfer function first, and then find the poles by assuming k infinity to get zeros and k equals 0 to get poles. And then the rule number 2 is the root locus is symmetry about the real axis. Rule number 3, basically we start with the first pole or 0, and then to the left of the real axis. So I said last week that rule number 3 is a bit complicated, so I don't know how to explain this rule, but when we sketch the root locus later, this rule will come will come in handy. Okay. So rule number 4 is the root locus always start at poles and then ends at zeros. Okay, always start with poles. And then the root locus approaches a straight line asymptote. So sometimes a root locus has an asymptote, sometimes no asymptote. Okay. And then number 6, we need to find the breakaway and break-in points. And sometimes there are no breakaway or break-in points for your root locus. Same with JW axis crossing. And also number 8, angle of departure and arrival. These are for complex pole, and arrival for complex zero. Okay, so let's look at the example given in slide 4C. So we have discussed example 1 here. So let's do this example. Okay, so given a unity feedback system, forward transformation, determine the root locus sketch, JW axis crossing, value of K at imaginary axis crossing, breaking point, and angle of departure from complex poles. Okay, so let's try do this question. Okay, so the question given to you is say that it's a unity feedback. So unity feedback means that your system is in this form. So the feedback here is unity, meaning that H equals 1. Okay. So for unity feedback, you can straight away find the poles and zeros from GS. But if non-unity feedback, then you need to determine the closed loop transfer function. Okay, so the first step you need to do is you need to find poles and zeros. Okay, so for poles, you use denominator. So s squared minus 4s plus 13. So this one you need to use quadratic formula. Okay. Okay, so you get 2 plus minus 3j. Betul tak? Okay, and then you need to find the zero. So 0 is s equals minus 2. Okay, so for poles, you need to use denominator. And for 0, you need to use numerator. Okay. And then after that, if you get this sort of question where the question number 1 asks you to sketch the root locus first, so I will suggest you to answer question 2, 3, 4, 5 first before you sketch the root locus, because sometimes we don't know where is the JW axis crossing, or maybe you don't know whether the root locus has crossing or not. So try calculate everything else first before you sketch. Okay. Okay, so let's find the JW axis crossing. So for JW axis crossing, what we need to do is we need to determine the closed loop transfer function. find the denominator and then use the denominator on Route-Hurwitz table. Okay, so find the closed loop transformation. So TS equals okay, simplify. Then we use the denominator. Okay, and then you do the Route-Hurwitz table. So we start with S square and then S. Okay, so from the Route-Hurwitz table, use row S1. So K minus 4 equals 0. And you get K equals 4. And then use row S squared. So you get S squared plus 2 times 4 plus 13 equals 0. So S squared plus 21 equals 0. S equals plus minus square root 21 J. Okay, so here the answer is plus minus 4.58 J. So this is the frequency or the JW axis crossing. And this is the value of K at axis crossing. Okay, so the purpose of this point, JW axis crossing, is the point where system is marginally stable. So sometimes in exam, the question asks you find the value of S and K when the system is marginally stable. So the question basically asks you to find the JW axis crossing. Okay, and this is the value of K at marginally stable. And then question number 3. So we have done question number 3, and then question number 4, the break-in points. So we have a break-in point at here, -2. So to find break-in point, basically you need to use the formula sum. Okay, sum of 1 over sigma minus 0 equals sum of 1 over sigma minus poles. Okay, so our 0 is -2. So sigma plus 2 equals 1 over sigma minus 2 minus 3j plus 1 over sigma minus 2 plus 3j. Okay, simplify. Okay, since you will do the exam online, so you can do this in Symbol Lab ke or Math Lab, okay? Tapi kalau exam tu dekat face to face, kena kira sendirilah. Okay, so you get okay, so you have two breaking point, okay, at -7 and at 3. Okay, we will see later which of this point is the correct breaking point, okay? And then the last question is determine the angle of departure from complex poles. Okay, so angle of departure is for complex pole only. So here our pole is 2 plus minus 3j. Okay, so let's try find the angle of departure. Okay, so theta 1 is 90 degree and theta 2 is tangent minus 1 3/4. So tangent minus 1 3/4 is tak boleh kira. Okay, tengok jawapan. .7. Okay, so to get the angle of departure, so theta 0 minus theta poles minus 180. So here 36.7 minus 90 minus 180. So you get negative 233.3. So this angle is measured from negative x-axis. So this is theta, meaning that this angle here is 36.7 here. Oh no. A 126.7. Okay. So this angle here also the same, 126.7. Okay, because it's symmetry, so these two angles are the same. Okay, so we get all the information needed from the question. So we get question 2, 3, 4, and 5. So now let's sketch the root locus. So to sketch the root locus, first you need to plot all the poles and 0. So the 0 is here at -2, and the poles are here, and then the angle is somewhere here, and then the JW axis crossing is at 4.58, maybe here. And then we have the break-in point. Okay, so the root locus will start from poles. So it will start here, and then will end at 0. So our pole is 2 plus minus 3j, and 0 is at -2. So here you have two poles and 1 0. So we need to add one more 0 so that their number are equal. So here another 0 is at infinity. Okay, so one 0 is at -2 and the other is at infinity. Okay, so since our root locus start from this pole here, meaning that the root locus will never go backward. Okay, so our breaking point is -7 here, so it cannot be 3 here, because if the breaking point is at 3, then your root locus will go backward. So your root locus will start from poles and will go to the 0 here. So meaning that the root locus will go forward. So your root locus will be something like a circle. So put a arrow direction here. And then one of the branch will go to the 0 -2, and the other will go to infinity. Okay, so there are two branches, and make sure it's symmetry about the real axis. Okay, so it is something like this, okay, a circle. Tapi lukisan saya tak cantik lah, okay. So nanti lukislah lawa-lawa. Okay, so this is if you use MATLAB, you will get you need to use this code. And you will get something similar to the answer. Okay, so your locus will start from poles, and then one of the branch will go to the 0 minus 2 here, and the other will go to infinity. Okay, so let's look at example number 2. So here, the example given is in unity feedback. Okay. So the question asks, determine the exact point and gain where the locus crosses the 0.45 damping ratio line. Okay, so question number 1 here. Basically, question number 1, you cannot do it manually. To do it manually, it's very, very, very hard. So question number 1 here, you can use it, use MATLAB, okay? So we skip question number 1. And question number 2, the exact point and gain where the locus crosses JW axis. Question number 3, the breakaway point. And question number 4, the range of K. So the question here doesn't ask you to sketch root locus. Okay, so let's look at how we can answer question 2, 3, and 4. Okay, so the transfer function GS. Okay, so the first step is to determine the poles. So poles is S minus 2 minus 4. And then zeros. So S equals okay. And then the exact point and gain where the locus crosses JW axis. Okay, so question number 2, you need to find the closed loop transfer function. Okay, so closed loop transfer function equals so the denominator is okay. We use Route-Hurwitz table. Okay, so use row S1. So you get K equals 3/2. So this is the gain at JW axis. And then use S2, S squared. Okay, so this is the point, okay, of frequency at JW axis. Okay, so question number 3, the breakaway point on the real axis. Okay, so to find the breakaway point, you use the sum formula. Okay, so 1 over sigma minus okay, and then simplify. And then panjangnya. Okay, ni guna calculator. Kalau tengok jawapan dekat somewhere 3, okay. Okay, saya tak ada calculator. Tak larat nak kira dah. Okay, you will get two values here. One is at negative, around -3, and the other is somewhere positive, maybe +4. So you will take the -1, okay? But you will decide to take negative when you see the sketch, okay? When you sketch the poles and zeros. Okay, so from the calculation, you cannot decide yet, okay? So you need to look at the sketch. So if you sketch the poles and zeros, so your root locus will start from poles and ends at 0. So if you have a breaking point here, so your root locus will never exit this point here. So basically your root locus will travel and then stop here. Okay, so it will never go beyond this 0 to get to this breaking point. So that's why you can cancel this minus positive breaking point here. Okay, so if let's say your 0 is here, for example, then there are two breaking points. Okay, so this is not a breaking point or breakaway point, okay? And then question number 4, the range of K within which the system is stable. So this you can use route Hurwitz, okay? So from the route Hurwitz, so we can just continue from this calculation here. So you can look at first column. So K plus 1 must be positive. So you get K bigger than -1. And 6 minus 4K must be positive. So K must be bigger than 3/2 or smaller. And then 20K plus 8 bigger than 0. So K bigger than minus 8/20 or 2/5. Okay, and then you can draw the number line. So minus 2/5 minus 1 3/2. Betul lah. Okay, so the first one is bigger than -1. The second one is less than -3/2. And lastly is bigger than -2/5. So the range where all lines intersect are here. So the final range, the range of K, Okay, so for stability. So if you look at this range, then this value here is when the system is marginally stable. Okay, where the root locus crosses the JW axis, and this is means that if your k is bigger than 3.3/2, then the system will be unstable. Okay, so somehow macam betul lah, okay, betul sebab if your range is more than 3/2, meaning that if you find your range is more than 3.3/2 for stable system, meaning that your answer is wrong, because kita tahu tadi based on question number 2, 3/2 is the system is marginally stable crossing at JW axis. Okay, so if you look at the root locus, so especially for question take home quiz question take home quiz number 1, the last question asking you to describe the system stability from the root locus. So if you look at this root locus, then you know that at this point here, the system is marginally stable. Meanwhile, at this range here, the system is unstable. And within this range, the system is stable. So you can say that the root locus is the system is unstable for the root locus uh, from this range, okay, from 2 until 0 here. And then starting at this point, the root locus is stable. Okay, the root locus shows for stable system. Okay, so if you look at the range, then you can say that for k bigger than 3/2, the system is unstable. And for k less than 3/2 until -2/5, system is stable. Okay, so let's look at the third example before we end our lecture. Okay, so in this question, the same thing. The system is unity feedback. So you can find the poles directly from the forward transfer function GS. Okay, so poles is okay, and then zeros. And then question number 1, we can do it last kali. So question number 2, imaginary axis crossing and the value of k at imaginary axis. So we need to find the closed loop transfer function. So closed loop transfer function Okay, we take the denominator. Okay, we use the Rab-Hurwitz table. Okay, use S1. So this is the value of K at imaginary crossing. And then use row S2. So K plus 1 to S squared plus okay, so this is the imaginary axis crossing. And then the question asks the break-in point or breakaway point. So to find this, you need to use the sum 1 over sigma minus 0 equals sum 1 over sigma minus poles. So 1 over sigma minus 2 plus 1 over sigma minus 4. Okay, and then simplify. Okay, simplify, you get okay, kira akan dapat 2 sigma. Okay, so you will have a breakaway point. Okay, so how to determine which point? So you can sketch first. So it will start from here and then break in. Okay. So break in lah, bukan breakaway. So the point is here. Okay, this is the point. And then the next question, the point and the gain where the root locus crosses 0.5 damping ratio. So here, this question, MATLAB, okay. Okay, lastly, the range of K for which the system is stable. So you can use the Raphowitz table that you have created. So K plus 1 bigger than 0. You get K bigger than minus 1. 6 minus 6K bigger than 0. You get K smaller than 1. And then 25 plus 8K bigger than 0. You will get K bigger than minus 25 over 8. Okay, do the number line. Okay, so all the lines crossing here. So your K is in between minus 1 and 1, okay, for stability. Okay, so just now we find the value of K at imaginary axis crossing is 1. So for K bigger than 1, then the system is unstable. And if you look at the root locus, okay, so this is the root locus. So the system is stable on here. So at this line here, the system is marginally stable. Okay. And at this point here, at this root locus here, the system is unstable. So ada soalan? Okay.
Macam mana nak tengok ke tak?
Sorry, tak dengar. Type soalan.
Macam ni. Okay.
Okay, tak apa. Take time. Take your time. Macam mana nak tahu graph stable, unstable? So, benda ni kita dulu lecture berapa tak ingat. Kita belajar bahawa kalau poles is on the right hand side of the the S-plane. So, if your poles is on right hand side, then the system is unstable. If the poles are on the left hand side of the S-plane, then the system is stable. If the poles are on the JW axis, the system is marginally stable. So root locus ni, basically root locus ialah plots of poles bila kita tukar K tu. So kita tukar K value, kita plot poles dia. Tukar K value lagi, kita plot poles dia. Ya, kita follow yang graph ni, okay? Follow yang saya cakap tadi tu. So root locus ni basically is the sketch or plot of poles. Okay, so sebenarnya garisan ni sebenarnya ialah poles. Okay, dekat point ni, contohnya dekat point tengah-tengah ni ada poles dia. So at this point here, for example, the poles for a system, tapi K dia berapa? Ada nilai K dia yang tertentu. So to determine the value of K, you kena guna formula yang kita belajar dalam lecture 4A. Dalam lecture 4A kita buat ada garisan and then kita find the angles. Kalau angle tu 180 darjah, meaning that this point here is on the root locus. Lepas tu baru kita cari dia punya gain M sama dengan K over apa benda tah, GH, lupa dah benda. Yang tu nak cari K. So basically the sketch here is the sketch of poles. Semua ni poles, ni poles, ni poles. Sampailah zero ni. Zero ni pun sebenarnya poles, tetapi the value of poles at zero here is when K is infinity. So basically at K infinity, poles akan jadi zeros, okay? At K equals 0, dia jadi poles of the transfer function, okay? At K equals 0 lah. Okay, when K equals infinity, the zero of the transfer function is basically your poles. Tapi poles yang dekat K infinity. So K tu yang menyebabkan adanya root locus ni. Kalau kata tak ada K, let's say your transfer function here, you don't have K here, tak ada K, then it becomes a single dot je lah. Titik je. Tapi K tu yang menyebabkan dia ada sketch tadi. Okay, so tujuan buat root locus ni, kita nak tengok system stability without finding the range of K lah basically. So dari root locus ni kita boleh nampak dah kat mana sistem tu stable, kat mana dia unstable. And then from there maybe we can determine what is the value of K. Okay, so you can try the take home quiz that I give to you. So that all of that are past year question. So semua soalan tu saya yang buat. Kalau saya buat, saya tak suka buat ikut norma lama. Saya suka buat ikut norma baru. So here soalan-soalan yang dulu-dulu macam ni lah, okay? Tak susah pun, ada orang boleh jawab. Okay, ada orang boleh jawab maksudnya okay lah maksudnya. Ada orang yang tak boleh jawab langsung. So tak boleh jawab langsung meaning dia tak faham apa root locus, okay? So dari macam sem lepas, dari kelas saya dalam 100 orang tu, maybe separuh boleh jawab, okay? Boleh faham apa benda yang soalan tu nak, okay? Yang separuh lagi tak boleh jawab tu, maybe dia ikut step ni je soalan dia, okay? So kalau tahu dia punya meaning of the root locus, apa benda, setiap benda yang kita cari tu, so insyaAllah boleh jawab, okay? So you can try the other examples. Okay, yang ni assignment ni tak ada, okay? Ni just example. So tu je lah untuk root locus. So you can submit your take home quiz number 1 and also submit take home quiz number 2 before Monday 8 AM, okay? 8 pagi. Okay, so saya perasan ramai yang hantar lambat quiz. Tak ramai lah dalam 10 orang. Saya dah cakap minggu pertama hari tu, lambat akan ditolak markah, okay? Walaupun ada markah, tapi akan ditolak lagi. So try submit within the time given. saya tahu mungkin ada yang ada masalah, maybe dekat rumah maybe bising ke, maybe internet tak ada. Tapi try cari masa untuk buat, okay? Try ask your friend for help. Memang susah sikit belajar online. Okay, saya pun susah. Maybe tadi dengar baby menangis kan. So macam kelang kabut sikit. Okay. So try belajar dengan kawan. Benda sama macam face to face. Belajar dengan kawan, janganlah tiru bulat-bulat. Okay. Kawan mesti marah kan, mesti tak puas hati. Kawan kita ni ambil jawapan kita, tiru bulat-bulat je. So tiru tu try lah tanya dia soalan ke, kenapa dapat macam ni. Pandai-pandailah pujuk dia, okay? Janganlah simply tiru, okay? Sebab kalau kita pun tak suka kawan kita tiru kita bulat-bulat kan. Tak kisahlah assignment ke quiz ke. So try fahamkan, try belajar sama-sama, try tolong kawan ke, okay? And this Wednesday tak ada kelas. So we will start new topic next week, Monday. And please finish your quizzes and also your project, okay? And satu lagi, kalau section lain tak banyak project dengan quiz, jangan compare, okay? Kelas saya memang banyak quiz. Sebab quiz yang saya bagi tu sebenarnya exercise untuk korang, especially untuk jawab exam, okay? So kalau saya tak bagi exercise, nanti kan macam tanya pula kenapa tak ada exercise atau boleh jawab exam. So take all the quizzes as an exercise, okay? Sebagai exercise, janganlah anggap dia sebagai bebanan. Okay, kalau rasa macam stress dengan subjek ni, you can drop. Week 10 kena bayar RM100 kan? Okay, sentiasa boleh drop dan boleh tukar section lain, okay? Untuk next sem. Okay, lepas ni kalau rasa macam nak bagi tahu junior, Dr. Jamil ni ajar banyak quiz, boleh bagi tahu, okay? Tapi saya bagi quiz semua tu untuk korang juga, bukan untuk saya. Saya tak dapat apa-apa benefit pun dari quizzes, okay? Okay, dah penat Bebel. So that's it for today's class. So we will meet again next Monday, insyaAllah. Assalamualaikum and goodbye.
Thank you, sir.
Thank you.
Thank you, Doctor.
Ashwin tak ada makan lebih.
Thank you, Doctor.
Thank you. Thank you.